SAFE-10-T project is a European Union funded initiative under the Horizon 2020 programme.
So it came as a response to a call from the European Commission. What they're concerned about is safety along networks.
The fact that they were built maybe 100 years ago and they've been deteriorating ever since, coupled with the increase in traffic loading that we're seeing on both our road and our railway assets. And then obviously superimposed on that, and very topical at the moment, is the impacts of climate change. The focus really is on how we can improve safety across the 10T network.
What we're dealing with is transport networks, and what we used to deal with is single mode. So we used to work for a railway company or a roadway company, and what we were trying to do is help them to move away from making decisions based on old-fashioned methods, like they were making risk decisions by going and looking at things. So they would look at a bridge and say, okay, say it's safe or it's not safe, we should do something.
So what we can say that so far the decisions were mostly done on a reactive, in a reactive manner. So we go, make a visual inspection, see the crack and repair it. So we really want to prevent occurrence of cracks or any damages.
So we started off by trying to be more scientific in our approaches. So use sensors, use advanced models to say how safe an individual piece of infrastructure is. Then we moved it across a network, so we looked at different types of infrastructure, so bridges and tunnels together, but for a single owner like a railway. And now for the first time we're moving across the modes. So this is a quite new approach.
The approach that we're taking is one of combined expertise.
A lot of the problems that we have, like climate change effects and population growth, are different in different countries. So we need to look at the problems across Europe, and we need to tackle as many as possible.
Data analytics, software engineers, civil engineers, social scientists to understand the needs of people, and how they change over time.
I'm responsible for performing traffic simulations during maintenance projects. So what actually happens if due to a maintenance project the bridge or tunnel is closed, what is then the impact on traffic jams or other behavior of people?
The idea was that we develop a decision support tool which takes into account different components from reliability, monitoring, and then assessing the consequences of different interventions decisions.
Showing graphs, showing the risk of the bridge and each of the options, like different maintenance plans.
By implementing monitoring sensors or the embedded monitoring system, we want to improve our performance models, and based on the prediction of the future performance, we will make decisions.
And you can, insert the maintenance plans you are interested in, compare them given the risk they each give to the bridge, as well as the consequences.
So we're working on things like individual objects, like an individual bridge or an individual tunnel. And we're really trying to understand what the safety level is, how likely are they to be impacted by these effects like climate change effects or increased loading. So we're working at this level and then expanding this decision making across the whole network. So we're doing things like, if we want to increase the safety of a bridge, we might need to close it for a little while. And we take the impacts of closing it into account. So we run a life cycle cost to see what's the actual financial cost, what's the environmental cost, what's the cost of users, like people trying to drive around the city of Rotterdam, if we temporarily close the bridge to increase its safety. So those types of things we're trying to do.
The benefit of the monitoring for the owner is that the decisions will be made proactively, and finally it will save money for the owner.
It's not just about saying, here's a whole load of data, this is what it does. It's also about helping people to visualize the impacts.
The main project outputs are going to be applied on different demo projects.
Each of those case studies or test sites are being used to look at different aspects of safety infrastructure.
One is the Rijeka tunnel in Croatia, one is the Severn Tunnel in England, and the third one is a case study in the port of Rotterdam for the Netherlands. And I'm mainly involved in this project at the port of Rotterdam. So there we are analyzing a bridge and combining all aspects of the SAFE-10-T project within this bridge or within this asset. So including the reliability analysis, so the structural integrity of the bridge, but also the traffic delays resulting from a closure of this bridge or several maintenance options, and a life cycle cost analysis for each of the options within the bridge. And then these are combined within the decision support tool, such that we can demonstrate the complete project within this case study.
So my involvement is to provide information to the team on the Severn Tunnel itself, because that's a demo project. This location was taken as a test site because it's very complicated in terms of maintaining the tunnel itself. The material degrades quite rapidly, and we want to look at new ways to intervene within the tunnel to allow us to manage the tunnel better going forward. So what we're trying to do at the Severn Tunnel is identify defects through image recognition, and we're trying to classify defects to allow us to intervene at the right time, depending on the severity of the defect.
So the demo project in Croatia is involving a tunnel, a railway tunnel. It's called Tunnel Brajdica, and the tunnel is a part of the big port of Rijeka. So the port of Rijeka is multimodal interchange place where you can switch from ship to the railway or to the highway. The railway tunnel is more than 100 years old. It has been built in 1900. And the renovation project started this year. The idea is that we have to extend it, make a bigger cross-section, and of course to strengthen the tunnel structure. But the main focus is how to integrate monitoring in the future decision-making process. So for the owner, we want to decrease the uncertainties. We want to know better what's going on with the rock above the structure, so above the tunnel and in the tunnel itself. And we want to prevent any bigger damages in the tunnel itself.
I'm Ramona Vlela, a researcher at the Institute of International Sociology of Gorizia. We were the partner responsible for Work Package 5 integration and dissemination activities. What we did is create consultation moments, if you want, in between the developers and experts and stakeholders in different moments of development of the decision support tool. Basically to make sure that whatever we develop as a consortium will comply with the needs and requirements to the final users, with the end users. It is a challenge, but then again, it is also a satisfaction when you see you manage to keep them engaged, keep them feedback on your inputs, and it's also a satisfaction building together, making a team outside of the partnership as well in the development of the tool. So I would say that this is a challenge turned into an opportunity and hopefully to a very good result.